Hello everyone, in this tutorial I'll take you through pump slowly, fetch quickly PSFQ protocol. So here, before we actually discuss this, so there are few things that which we are supposed to take off. So here there are two different paths in a wireless sensor network. One is forward path, that is, if data is traveling from sensor to the sink, we call it as forward path. And in a similar way, if the path reverses, that is, if there is data flowing from sink to the sensors, we call this as reverse path. And this reverse path is quite important when compared to that of forward path because during communication from sink to the sensor, sink can send some commands in order to manage the network. So network management commands are usually sent from sink to the sensors. That is why reverse path is very much important compared to that of forward path. Basically in forward path it so happens that due to correlated data, because many sensor node would have been deployed, so all these collected data will be of similar value. So even if there is any losing of the data, it doesn't matter. But here, if any command misses out, that might lead to devastating effects. So by now we did got to know that reverse path is very much essential. So here you can see there is this directed line going from sink to the sensor node where dissemination of control signal is happening. So this reverse path is generally used for network management tasks. While the sensor to sink path may tolerate information loss due to high correlated data generated by the sensors, reverse path requires one-to-one communication support to reliably disseminate control information that is sent by the sink to each sensor. Pump slowly and fetch quickly protocol provides three main functionalities. One, the very first functionality is pump function. Second is fetch operation. Third is status reporting. So in pump operation, since reliability is very much important when compared to that of timeliness, pump slowly, as the name itself indicates that it's slowly pumping. So thereby it is not paying importance to this timeliness, but for reliability. So PSFQ employs a slow pump mechanism that is based on slowly injecting packets into the network. In this case, each node on the route to the destination waits for specific amount of time before forwarding the messages. So it has to wait for a minimum amount of time t-min. So if I take you over here you can see that there is this sink and source, and the messages is being passed from sink to the source. And here there are three packets that which are being sent from sinks to the source. And after passing the first packet, this sink is waiting for minimum amount of time, that is t-min. And only after waiting for t-min it can send the second packet, likewise the third packet. And again this source has to so this source is getting the packet sent by this sink over here, and it is passing it again, it is forwarding the same packet, and again before it forwards the second packet, again it has to wait for a time interval of t-min. So this is pump slowly mechanism. So this is the very first function. Next we have this fetch operation. In case of packet error, so fetching means getting back the original message. So in fetch operation, in case of packet error, each node performs a hop by hop recovery to fetch the lost packets from its neighbor nodes. So here let's see how exactly it's fetching quickly. So here again let's consider there is this communication happening between sink and source, and sink is transmitting its first data, and after t-min time slot it is transmitting its second packet, but due to some noise in the channel this packet is getting lost, and after again t-min amount of time this sink is transmitting its third packet. But the source over here, this node over here, that which has not got its second packet, sends negative acknowledgement back to the sink. But let's say if we assume that this negative acknowledgement is being lost, it waits only for a timing of TR. So it waits for TR amount of time, that which is very less compared to that of Tmin, and it again sends the negative acknowledgement, so that this negative acknowledgement be received by the sink, and sink retransmits its second packet. So because this TR is very much compared to that of this Tmin, here fetching is happening at a faster rate. And along with that, we have one more operation which we call as proactive fetch operation, where let's consider this scenario between sink and the source, where sink is transmitting all its packets, packet 1, packet 2, after waiting for a time interval Tmin. Then it's trying to pass its third packet, but that is being lost. So this sensor node waits for a time interval of T. Because this is proactive, it waits for this time interval, and it takes initiative and sends the negative acknowledgement packet to the sink, and gets the third packet back again. So this is pump slowly, fetch quickly, proactive fetch operation. And finally, the third functionality is status reporting. PSFQ also provides reporting functionality that creates closed loop communication between sensors and sink. Through this functionality, the sink can collect information related to the operation of the network. So this is about PSFQ, and in our next video, let's go through congestion detection and avoidance protocol.